Hello and welcome to this lecture on project selection and models. Project selection. Now, no organization can pursue every opportunity. Resources are limited and you have to make choices. So it'd be nice to do every single project and every single idea that anybody in the organization has, but you simply can't do that. There's got to be some way that you screen potential projects and decide which projects you're going to explore. We need to use a model to help you consistently evaluate one project from another project so that you can figure out what the winning projects are. And by winning here, we're talking about best bang for the buck, the most return on investment, having the best bottom line results for the company, for the organization, for the firm to move forward. So this idea of coming up with some standard models to help managers pick winners was first written about, and probably before then, but famously was written about in 1983 by a guy named Ch03, and he identified 5 characteristics of, or criteria for project selection. First of all, a screening model should be realistic with respect to key resources such as money and personnel, and it must be realistic in terms of the risks involved. So you don't want to be make decisions based on fantasy or lottery possibilities, lightning striking. You want to be realistic. Second thing that Ch03 pointed out is that a screening model should be capable of responding to changes in project conditions, criteria, and constraints, because conditions, criteria, and constraints in the project will change over time, and the model that you're using needs to be capable of handling that. Third, the screening model should be flexible enough to be easily modified if necessary. Tax laws change, building codes change. There are things that are assumptions when you move forward with a project, the price of gas, the trade value of $1 versus €1, whatever. These things can change, and that's part of the weighing of projects potentially, and your model needs to handle that. Your screening model, your model for choosing between projects, should also, step 4, be easy enough to use that various people in the organization, in fact everybody in the organization that wants to make a model decision, can use it. And the model should be easy enough to use that people can get the results rapidly. They can plug in the numbers and get the reports, the comparisons back quickly without a lot of training, without a lot of effort, without a lot of manpower. And the 5th criteria that Ch03 came up with is that a screening model should be cost effective, so that the cost of using the tool is relatively low compared to the cost of the project itself. If you have a decision-making process and it costs $100 million to work the tool, the model, but you end up with the exact better project, A versus B, but the difference between A and B is only is less than that, then it was a bad use. The model needs to be cost effective. Now, bigger projects can have more complicated and expensive models, but a lot of the projects a company comes up with are relatively small budget, and you need a nice small cost effective model in those cases. Our authors go on to add a 6th criteria, which is that the screening model used should be broad enough to be applied to multiple projects, thereby supporting general comparisons of projects alternatives. Because again, the idea here is that we've got multiple projects, we've got alternatives, we've got options, and we're trying to choose which model to use that'll be the best use of our resources. Screening and selection issues. Risk, unpredictability, new untested technology, lawsuits are an issue. Commercial factors, market potential, the ability to grow market share or break into new market areas with a new product. Internal operations, the physical plant, the machinery involved, the personnel involved, training involved, those kinds of issues, and additional things. Corporate image, any patents that are involved, just the fit, what's our, we're trying to be a green organization and work for that audience and so on. All those things come into play. All models are only only partially reflect reality and have both objective and subjective factors involved. In other words, the most complete model in the world is still only a model. It's only a partial reflection of organizational reality. In physics, the same thing. I don't know if you had a physics class, but in physics you do physics models, but the instructor says, look, we're simplifying the world. We're talking about, pretending there's no friction as we drag a box across the table. We're pretending that, gravity works a certain way when really the formula for gravity is a little more complicated between Newton and Einstein and all that. So we have models, but they're going to be only a partial reflection of what's going on in reality. But they're usually good enough to make decisions, and that's what we're trying to do here. These models have both objective and subjective. Objective being factual, data-based, and subjective being you like something, and it's not a quantitative, but rather a qualitative, touchy-feely, emotional. Your subjective rating might be different than my subjective rating, but if we measure, how tall a box is, that's a objective, quantitative number, and we should get the same results there. And our models have both of those. We have some specific numbers we can deal with, but we also have to have some subjective touchy-feely. I think that this is going to be good for the company. I think that this has low risk or high risk. It's hard to. There's both. Okay, so there's 4 models that we're going to look at. First of all is a checklist model. This is the simplest of the models. When we go through our reading here, it's probably the least interesting. We want to pick a project based on this, 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 and this. So you have to agree on the criteria, and one of the problems with this is we're assuming that all the criteria are equally important, and they're probably not. The profit that a project makes is going to be a pretty heavy factor in most cases. But in a checklist model, profit doesn't have any more of a checklist than it's going to use a certain machine on a factory floor. There's no way of distinguish between these. Checklists are valuable for recording options and encouraging discussion. They're probably not what you really want to do when you want to get down to the nitty-gritty of making a decision between 2 or 3 or 4 different valuable projects. The reason is because a checklist screening model, it doesn't consider the criteria one more important than the other. So here we see a simple 4 projects, and we're going to look at these 4 projects: alpha, beta, gamma, delta, and we can see some criteria involved. The cost, the profit potential, the time to market, and the risks. So 4 pretty fair criteria to be looking at. Alpha, we can see on this performance checklist, alpha project has a high cost and it has a low potential profit, medium to market, and low risk. We can look at that. Probably something that's high cost and low potential profit, probably not the project I'm going to go with. Whereas if we look at the Delta project, it has low cost but low profit potential. If we look at the Beta project, it has medium cost, medium profit. Gamma has high cost but high profit potential. Then other factors come into play: time to market, developmental risks, and so on. So that's a model, but again, it's very difficult to choose between these projects in this situation. So we need something a little more substantial. So our second method that our authors present in this chapter is a simplified scoring model. Each project receives a score that is weighted, a weighted calculation, the sum of its grade on a list of criteria. And this means we have both a criteria and weights for the criteria. So we get to multiply those together and come up with a specific score. Now the purpose of this score is to compare between the projects, but you want to not make false conclusions based on these scores, and I'll say something about that in just a second. It has an advantage. This simple scoring model has an advantage over a checklist model because decision makers can treat one criteria is more important than another. So cost, for example, and potential profit can be given more weight than some other factors. So here we see again our same four projects: alpha, beta, gamma, delta, and we have our same four criteria: cost, potential profit, developmental risk, and time to market. But in addition to having the same scores that we saw before, right? So in alpha, remember, the cost was high but the potential profit was low. What we've added to this is column A, which is new, where we said, okay, these are the weights. And in this case, interestingly, cost is weighted low. And notice that the weights, 1 for cost, 2 for profit, profit potential, 2 for development risk, and 3 for time to market, those are the same for alpha, beta, gamma, delta. Right? Alpha is 1, 2, 2, 3 for the weights. Beta is 1, 2, 2, 3 for the weights. Gamma is 1, 2, 2, 3 for the weights. And delta is 1, 2, 2, 3 for the weights. We're not changing those. We're saying that regardless of these projects, time to market matters. And then there are instances where being first to market is the #1 priority, and clearly that's the case here. We're trying to choose between these four potential projects, and part of our decision process is we want to be first to market, or we want to hit some critical deadline, some critical trade show. It doesn't do any good for the project to come out after the trade show. You really need to have it there at the trade show ready to demonstrate, or whatever. There's a number of reasons why time to market might actually be critical for a given project. Typically you think about cost or profit being higher rated, but I like that in this example they're making time to market. So because time to market matters so much, we might see that, for example, the beta project benefits from that because it has a score of 3 high for time to market, whereas project gamma has a low time to market, right? It's a 1 in column B for project gamma. It has a 1 value. And then when you multiply A and B, when you multiply weight and score, you get a combined score, and you can add those up. So we can see that project alpha has a combined score of 13, beta combined score of 19, gamma combined score of 18, and delta 16. So beta really jumped up there, even though gamma was probably ahead of it before. Beta ended up being a little bit higher. Now we have to be careful here. Don't be tricked into drawing quantitative conclusions. In other words, beta has the highest score, and so it's the best choice. So we can make that claim, but we can't say how much better beta is than alpha or something else. In other words, for round numbers, if there was A, B, and C, and A was 10, and B was 20, and C was 30, you can't say that B is twice as good as A, that 20 is twice as good as 10, or 30 is 3 times as good as 10. You can't make those comparisons with this model. Now method 3 is going to allow you to make some more specific conclusions, the analytic hierarchy process. And this is a 4-step process. First of all, you come up with a hierarchy of criteria and subcriterias, second level items for each main level. In this example, figure 4, we see that the first level criteria is financial benefits, contribution to strategy, and contribution to IT infrastructure. Those are our criteria, or our first level goals. Now each one of those criteria has a subcriteria, so each first level has second level goals. So financial benefits, for example, there's the short-term benefits of the project, and then there's the long-term benefits of the project. Strategy has 3 examples: market share for product X, retaining existing customers for Y, and improving cost management. So that those are all benefits contributing to strategy of this project if it gets funded. Okay. The second step is to allocate weights to these criteria. So we identify the criteria. That's step 1, first level and second level. Now we want to go through here and identify weights to these steps. A pairwise comparison approach is to split the weights assigned to the subcriterias and have those things calculate out together. So if we look at this, for example, looking just at that first criteria and its 2 subcriterias, financial benefits, we're going to give it a weight, a percentage, 52%. I don't know what the contribution to strategy and contribution to IT infrastructure are, but they're going to add up to be 48%. because that'll give me a total of 100% for my 3 first level goals. So financial benefits are 52%. Now the short term, the sub-criteria for financial benefits are short-term and long-term, and I got to break those up in a pairwise comparison so that they add up to 100% as well. And we're going to say, well, long-term goal is, it's more important than our short-term goals. It's more than double, right? 70 versus 30%. Okay, so that's great, but by putting these numbers in here, I can make specific calculations. I can give a specific value for the long-term financial benefits. That would be the 52% for the criteria first level times the 70% for the sub-criteria second level, and just pull a calculator out or a spreadsheet, that's 36.4%. The short-term financial benefits would be 52% times 30%. And I don't know what that is off the top of my head. I don't expect you to either, but with a calculator we could figure that out. I guess it doesn't hurt to remind everybody that 52% and 0.52 are the same thing. When you have the percent symbol in a number, it means divided by 100. So if I can't take 52% and just drop the percent sign. I don't have 52. For me to drop the percent sign, I have to divide it by 100, which is the same thing as moving the decimal 2 places to the left. And in fact, a percent is actually, a 1 and a 00 reorganized. Percent means per 100, and divide by 100. So that 0.52 is another way of representing, without the percent symbol, is another way of representing 52 with the percent symbol. Okay, end of math lesson, but just a quick reminder there of where we're getting those numbers. There's nothing magic going on. We're just representing percent with the percent symbol and without it in decimal format. So we can come up with these percentages for our criteria and sub-criteria. We also want to take the subjective elements that the project manager is going to choose, and we want to give numeric values to those as well. So in this figure we see that our subjective elements that we're going to put on here are poor, fair, good, very good, and excellent. So we happen to have 5. You could have more, you could have less. But instead of just ranking these 1, 2, 3, 4, 5 so that the gaps between each one of them are exactly the same, we put numerical values between these, and again they can convey some sense of relative closeness or distance. So poor and fair, the numerical values there are 0.0 and 0.1. Now good, the next one, doesn't become 0.2, which would be a natural linear growth there. It's 0.3. So poor and fair are closer together than fair and good are. And likewise, good and very good are further apart than fair and good, and very good and excellent are a certain point apart. We can take those numerical values and we can normalize those to 100% and come up with those values there. So whether we're talking about the numeric values, which add up to a 2 in this case, happen to, or we're talking about the the priorities there, which is we can get a percentage. We can add all those up and divide it by a number and come up with a percentage. Either way we can get these. And this bar graph just kind of shows us the relative weightings. You can see on the bar graph that poor and fair are both, they don't have very much weight in our bar graph. But it's not a perfect even stair step. And in this example, they're still kind of close. I've seen these where it can be even more dramatic. You might have 2 or 3 or 4 that are real close together, and then the top 2 are way, way off to the right. Okay, so now we've got scores, numerical values, for our subjective evaluation dimensions. The fourth step in the analytic hierarchy process is to determine the score, and at this point we've done the hard work. Now it's just plugging in the numbers. Now it's just multiplying the percentages for the pairwise first and second level scores times the numerical values we got for the ratings that we came up with, and we have some specific scores. So we see across the top of this chart that there's poor, fair, good, very good, and excellent, and there's the weights that we came up with those, where poor and fair are kind of close together and good's bigger and very good. We also see that we have our three main criteria: finance, strategy, and technology, and underneath those there are sub-criteria: short-term and long-term finance, 3 types of strategies, and our technology option. And those percentages, if we add all those percentages up at the sub-criteria level, those all add up to 100%, or they add up to 1. So I've got those rankings there. That's good. I'm going to use those numbers again in a minute. So I can go through my projects here. So project 1, the perfect project, and I'm going to take each one of these characteristics, short-term finance, long-term finance, market strategy, retention strategy, cost management strategy, and technology, and I'm going to rate those with my rating system: poor, fair, good, very good, or excellent. And again, that's subjective, and you need to get some people involved, some discussions involved. But this perfect project has an excellent rating across the board for everything. And if you multiply the excellent value times all those weights, you end up with a score of 1, a perfect score there. The aligned project, line 2, has a good short-term value. It has an excellent long-term value. It has a good market share, an excellent retention strategy, a good cost management strategy, right, and so on. If we look at the mixed one on line 5, it's got a poor short-term financial option, a fair long-term, a good market strategy, a very good retention strategy, an excellent cost management, and a good technology. And that seems kind of subjective, and it is subjective there, but we come up with specific quantitative results. So the value for number 5 mixed, the total there is 0.28. And the value for number 3 not aligned is 0.53. And we actually can say with some degree of confidence that the not aligned is twice as good of a project in its potential for our corporate goals as the number 5 mixed, because the total 0.53 is about twice the value of line 5, 0.284. These numbers do have meaning. We can make relative comparisons between these, and that's a nice part of the analytic hierarchical process, method 3. Okay, what about our fourth and final method that we're going to talk about in this video? So we've got these numeric scores. You can kind of see how we have these numeric scores in our total column that have some meaning. But what about breaking this into 2 dimensions? What if we actually were trying to choose between 6 projects, and we can say, well, we can do it, but here is this approach called the profile model, which allows you to think about risk and reward separately, and then combine those together in a plot these on a 2-dimensional axis, where we have perceived risk as our vertical axis and our potential return as our horizontal axis. Now, where do we get the values for the return? How do I know that x1 has the that exact return value and that exact risk value, and that x2 has a very high risk values because it's kind of high up the risk line, and it's 1/4 of the way out the return, perceived the potential return? The models that we were just using, like the analytic hierarchical process, might be where we get these numbers from. It might be something much more less formal. But the point is, we're thinking about both risk and return, and we plot it out in 2 dimensions. Now, what that allows us to do is it allows us to, if our plotting is accurate, it allows us to start to think about our projects and to start eliminate some projects. So, for example, I would probably not consider X2 or X4 as a potential project to invest in and move forward. Why not? Because they don't really have a risk-reward benefit. I've got X1 and X3 as potential projects. X2, yeah, I could do it, but the risk for X2 isn't worth it, because it's riskier than X3, but it has less return than X3. So why would I do X2, which you can see has higher on the risk axis, but it's further to the left on the return, so it's going to have less financial return and more risk? I wouldn't want to do that. Now, X3 and X1, I'm not sure about those, because X3, it's a little riskier, it's a little higher up, but it's also a little further to the right, so it's got more financial return. So I've got to choose between X1 and X3. X2 is right out. Same thing with X3 and X5. X5 is a little riskier, it's higher up, but it's also a little more financially rewarding potentially. It's further to the right. X4, yeah, it's riskier than X3, but its return doesn't benefit as much as X5 does. So we can make this efficiency frontier where we look at the that as far to the right and down as possible. We can consider just those projects. And X2 and X4 can be eliminated in this model because the risk-reward trade-off is less attractive than those in the efficiency frontier. We can also, as we consider this, say, well, there's some minimum desired return. It costs a certain amount of money just to do the project. And if the return from this project is less than what it costs, then it's not worth doing, regardless of the risk. I mean, I know it may succeed, but I'm going to lose money, right? So some things aren't worth it because they don't have a minimum desired return just based on the cost of doing business to invest in the project. Likewise, there might be some projects that have a lot of potential return on investment, but they're so risky that we're not comfortable going with them. So we can have projects where the risk level is too high regardless of the potential profit. So we can draw those lines there, and based on those minimum desired return, anything to the left of that minimum desired return, in this case X1, we're going to lop it off as well. And anything above the risk, the maximum risk, in this case X6, we're going to lop it off as well. We can see our efficiency frontier, we lose X1 and X6, so now we're just choosing between X3 and X5. Of our 6 projects using this profile model, we're able to identify the 2 most promising projects, and then we can make our decision based on that. Okay, so there's project selection and 4 interesting models to look at.